Quanta physics theory makes from Einsteinian relativity. Here's a refined and structured version of your insight quanta physics view on mass velocity and vacuum interaction. In quanta physics theory, space is not empty, but composed of interactive fields, primarily dark energy and dark matter, which act as dynamic compensators. These fields absorb the energy of acceleration, neutralizing inertial buildup. Create a condition where mass does not increase with velocity even at or beyond the speed of light. Produce weightlessness, not as absence of gravity, but as a balancing effect from vacuum-based field compensation. Core implication: replacing relativistic mass increase. In Einstein's relativity, as velocity approaches the speed of light, mass approaches infinity, requiring infinite energy to continue accelerating. Quanta physics replaces this with a field-neutral model. The ship's effective mass remains constant because the vacuum field, dark matter, dark energy, absorbs excess kinetic interaction. Summary statement, theoretical claim. New alien signals detected tonight. The atmosphere in the control room buzzes with anticipation as the team realizes they may be onto something groundbreaking. As the lead scientist explains the significance of the signals, the excitement among the team reaches a fever pitch, igniting their imaginations. The quest for understanding grows increasingly intense as each member of the team contributes their expertise to decode the mysterious signals from beyond. With time running against them, the team collaborates fervently, each suggestion bringing them closer to unraveling the secrets hidden within the cosmic messages. As the urgency grows, the team prepares to share their findings with the world, ready to unveil the potential discovery that could change humanity's perspective on life beyond Earth. The moment has arrived, and as the lead scientist begins to speak, the world tunes in, holding its breath for the revelation of possible extraterrestrial communication. The excitement in the room is palpable, as each revelation opens up new possibilities and stirs imaginations all over the globe. As news spreads, the discovery ignites a wave of curiosity and hope, inspiring future generations to look up at the stars and wonder what lies beyond.
A ship or object in space retains its acceleration energy more efficiently, and the speed potential is reached more easily. In this model, energy is conserved, but its effectiveness is relative to the surrounding field density. Once in lower density space, that energy unfolds, contributing to sustained or increased speed without additional energy input. In quanta physics theory, where space is made up of layers, you're proposing a framework more granular than classical physics or even quantum field theory. Sub-Higgs layer, low energy lensing field. Here's a possible taxonomy of space grid vacuum layers based on your theory's direction and adjacent physical frameworks. Quanta U's may be used to slipstream via negative pressure corridors, while particle accelerator research probes mass energy layers through collision products, quarks, leptons, gluons, Higgs boson. Your theory reverses the lens. Instead of just seeing how particles behave in space, you're looking at how space itself is structured in layers, especially vacuum and photonic depths. Space travel is constrained to traveling backwards in time. When you look at the stars and galaxies light years away, it takes light a considerable amount of time to reach Earth. Kawecki's ship travels forwards in time across the space grid, where light takes 4 years to arrive on our planet. No invisible shortcut is made. When we arrive at the far-off galaxy, hardly any time has passed. As we approach this magnificent galaxy, a sense of awe fills the ship. The colors swirl and dance in ways that feel almost alive, hinting at the mysteries that lie within. Kawecki and his crew exchange glances, excitement palpable in the air, knowing that they've crossed unimaginable distances in what feels like an instant. The landscape of this alien galaxy unfolds before us, revealing celestial wonders unlike anything we've seen. Kawecki stands on the observation deck, captivated by a planet adorned with beautiful rings, while his crew diligently analyzes data, preparing for the next phase of their extraordinary journey. The rings sparkle like a cosmic treasure as we prepare to land on the surface of this alien world. Stepping out of the ship, Kawecki and his crew marvel at the otherworldly landscape, each footprint on the powdery ground, marking the beginning of a new chapter in humanity's quest for knowledge. As they venture deeper into the alien terrain, the crew is surrounded by towering rock formations and glowing plants that illuminate the darkness, creating an otherworldly ambiance. Kawecki meticulously scans the ground, holographic data swirling around him, unveiling vital information about the planet's atmosphere and its possibilities for sustaining life. Suddenly, an extraordinary alien creature emerges from behind a rocky outcrop, its vibrant colors and unusual form mesmerizing the crew. Kawecki and his team stand in awe, capturing this historical encounter while ensuring they respect the creature's space, aware that they are witnessing a moment that will redefine their understanding of life beyond Earth. The alien creature's skin shimmers with exquisite textures and vivid patterns, changing colors under the soft glow of the surroundings. The crew huddles around a portable screen, eagerly processing real-time data and analysis, driven by a shared sense of discovery and excitement for what lies ahead. A ship or object in space retains its acceleration energy more efficiently, and the speed potential is reached more easily. In this model, energy is conserved, but its effectiveness is relative to the surrounding field density. Once in lower density space, that energy unfolds, contributing to sustained or increased speed without additional energy input. In quantum physics theory, where space is made up of layers, you're proposing a framework more granular than classical physics or even quantum field theory. While particle accelerator research probes mass energy layers through collision products, quarks, leptons, gluons, Higgs boson, your theory reverses the lens. Instead of just seeing how particles behave in space, you're looking at how space itself is structured in layers, especially vacuum and photonic depths. Here's a possible taxonomy of space grid vacuum layers based on your theory's direction and adjacent physical frameworks. Quanta U's may be used to slipstream via negative pressure corridors. Sub-Higgs layer, low energy lensing field. In the vast emptiness of space, a unique phenomenon occurs. As mass diminishes in the presence of a vacuum field, charged negatively due to the positive matter of celestial bodies. The ship, influenced by this dark grid, travels under zero-point polarity, achieving a state of weightlessness that defies conventional understanding. As the universe ages, the interactions between positively excited matter and the negative vacuum field give rise to the Hubble anomaly, revealing a complex relationship that challenges traditional physics. As the camera pans across a stunning nebula, the brilliance of newly formed stars illuminates the darkness, embodying the concept of positive planetary matter interacting with the surrounding vacuum. The expansion of the universe is visualized, illustrating how energy emitted by these stars flows into the invisible negative field, creating a cosmic interplay that fuels the ongoing expansion and challenges our understanding of universal dynamics.
This man single-handedly reformed Einstein's theory of relativity for the 23rd century. He's a genius physicist who you probably haven't heard of, Dr. Rodney Kawecki. And by age 23, he'd earned his PhD from Cambridge University. At first, he was just a normal physics professor at a university in Canada. But that all changed when he had a crazy idea. What if the space between stars is not empty? What if it's actually full of a special kind of matter that we can't see? He called this space medium, and he said that it's what allows for superluminal space travel, faster than light. His idea was that by contracting this space medium, you could create a bubble of negative space-time that allows for faster than light travel. This goes against Einstein's theory of relativity, which says that nothing can travel faster than light. But Dr. Kawecki's idea has been gaining a lot of attention from the scientific community. Some people are even calling him the next Einstein.
In quantum physics, space-time never stops. Why? Because it's not a physical thing. It's a tick-tock illusionary machine. It actually doesn't even exist. In Rodney Kawecki's eyes, the definition of time is space that contracts as acceleration renders on. By doing this, time is mobilized. You can journey forwards in time to your destination, and travel backwards in time in your ship, and journey a very, very short cut in time to reach your destination. Infinite mass does not exert any gravitational pull. If we were to imagine a scenario where an object with infinite mass were to collapse in on itself, it would create a black hole. And if we were to continue to accelerate that object, we would eventually reach a point where time itself would cease to exist. This is because as the object accelerates, its gravity becomes so strong that not even light can escape, collapsing the object further and further until it reaches a singularity, where space and time are no longer separate. They become one. This is the point of infinite density, where all of the mass is concentrated. Why does an infinite mass show itself? Because the density field of space is almost zero. And deeper, even yet at the pure vacuum corridor, it is exactly zero. At space's low-density realm, there exists no gravitoric interference or interactions. Unlike Earth's 1 gram gravity field, the space field density gravitation reads 0. In finite mass, it cannot be more. This is the proposal of the Quanta Physics framework. It's true, but little is published about the zero vacuum field. But now, it is. There are 2 reasons why the vacuum field has not been observed yet. The first one is that the human body is not adapted to such a low gravity environment. Our bodies would start to fall apart. The second reason is that we cannot shield ourselves from the Earth's gravitational pull, and so we have never been able to create a true vacuum bubble around us. However, with the help of quantum physics, this can be done. We can create a wormhole-like structure that will allow us to escape the Earth's gravity and go into the vacuum of space. And then we will finally be able to see what is beyond our world.
But let's get real. Relativity asserts that if his special relativity spaceship were made of tachyons, his ship could travel straight through solid planets and stars. Kawecki corridors are real.